Okay, so now we're recording. All right, so did I hear number 19?
Yes, please. I have the same numbers, but I don't know why it's less 10% like in the TBAC file. So I just want to know why is that?
Okay. And I thought I did 19 on here, but I guess I didn't. Okay, so this is the post-test for chapter 16. So we're on page 449, number 19. Okay, so it says the following solutions are ordered for a TPN. Travosol, which is amino acids, call it Trav, and they are 7.5%, and it's going to be 500 milliliters of this. And then dextrose 70%. And they want 300 milliliters of that. And then the sterile water for injection is going to be 200 milliliters. All right, so then they want to know what the final concentration of Travosol is for this. So it's basically, if you have 500 milliliters and 7.5% of it is Travosol, then how many, what's your final concentration going to be in the whole thing? So okay, so the whole TPN is how many milliliters?
1,000.
Yeah, so it's 1,000 milliliters. All right, I'm trying to keep an eye on who's coming in, like I don't want people to be waiting in the waiting room. Okay, so the final concentration, we have 7.5% and we have 500 milliliters of it, which is half of it. So half your bag is going to be protein or amino acids, which is the building blocks of protein anyway. So that's going to be one of those initial concentration times initial volume or stock. Yeah.
So the 500 mil, it's the stock?
Yeah. So 500 times 7.5 is going to equal 1,000 times X. Okay.
Oh, okay.
So yeah. So 500 times 7.5.
Because I use 7.5 and the stock volume I use 100 and the final volume I use 500 mil for Travosol, and the final volume for dextrose I use 300 mil. So this is
Okay.
Yeah.
So this is what you're starting with. This is your stock solutions. And this is, or stock volume, I should say, stock volume. And this is your stock, what do they call that? Stock concentration?
Yes.
I'm sorry, I've taught out of several books and I'm used to initial volume and final volume instead of stock volume and desired volume. So really you could call it anything you want as long as you're consistent with your calculations and the way you set it up. So this is our stock volume. This is our stock concentration, or what do they call that in here? Let me go back to the book because
it's stock strength, isn't it?
Strength, thank you. Stock strength, and this is my desired volume and my desired strength. Okay, so now I'm going to divide by 1,000, and my new stock, or my new desired volume in the whole thing is going to be 3.75%. Okay, so this makes sense because you start out with 7.5%, and then you're going to end up with twice as much. So twice as much is going to be half as strong, right? So your new percentage, since you've diluted it, is now 3.75%. Okay, is that making sense? Okay, now our dextrose, we started out with 300 milliliters of 70%, but I'm going to end up with more than 600, so I'm going to end up with more than twice as much. So it should be less than half the strength when I'm through with it, because I'm diluting it with a lot. So instead of 70%, it should be less than 35%. So let's go ahead and do that one. So I have 70% and 300 milliliters. 300 times 70 is going to equal 1,000 times X. Again, same thing.
I solved it wrong, but the funny thing that the number is the same, only the decimal point is different.
Yeah.
Yeah.
So I'm going to end up with 21%. Now, is that less than 35%?
Yes.
Yes. So that makes sense then, right? Okay. So then the last one is the water, and it's not asking about our percentage of water, and this is 100% water. Our stock is 100% water, so it doesn't matter, you know, what it ends up being as far as percent of water. Water is just added because, first of all, patients need water, and secondly, it dilutes the things that are in there so that they're not too strong. Okay, so there's your final concentration of Travasol, which is now going to be 3.75%. And the final concentration of dextrose is now 21%. And then if the TPN is hung at 0200, what time of day is that?
AM?
Yeah, 2 a.m.
It's the morning.
Yes, 2 o'clock in the morning. And it's run at 50 milliliters per hour. When will the next bag be due? Well, this is why I added up our totals here. Where'd it go? So I know that my TPN is 1,000 milliliters.
Yes.
And so we need to know how many hours it's going to take to run.
Yeah.
So we have,
So 20 hours.
yeah, we have 1,000 milliliters. And in 1 hour, it's going to run 50 milliliters. Yeah, 50 milliliters. So this will tell us how many hours it's going to run. So it's 1,000 divided by 50, which gives us 20 hours. Hours, it'd be 4 a.m. or it'd be 2 a.m. the next day, but you have to subtract 4 hours. So 1 a.m., midnight, 11 p.m., 10 p.m., and 10 p.m. is what in military time?
2,200 hours?
Yeah.
2,200.
So that's when the next bag is going to be due at 2,200. Okay, how are you guys doing with number 20 as far as figuring out how many milliliters of each one of those additives?
It's the easiest question, this one.
It's dosage calculations, isn't it?
Yes.
But the reason I ask is because all of the electrolytes that are measured either in milliequivalents or percents, or in milliequivalents per milliliter or millimoles per milliliter, like sodium phosphate, a lot of people confuse those things. So like with the sodium phosphate, it gives you 2 strengths. So this is number 20.
Yeah, I got all except when I got to base solutions. That's after that.
Okay.
Yeah.
Okay, so we want, let me just go over the sodium phosphate because I have a feeling people are going to want to see it. We want 12 MEQs. And my available strengths the stock strengths of sodium phosphate are 45 millimoles per ml, or, which is the same thing, 60 milliequivalents. No, it's 45. Okay, where am I going here? All right, what are you doing? Stop getting smaller. All right. I don't know what this thing is doing. There it goes. Jeez. Okay, so we either have 45 millimoles in 15 mLs. Come on, bamboo pen, or whatever your name is. Yeah, it's a bamboo pen. Okay, in 15 mLs, or 60 milliequivalents in 15 mLs. Okay, so the thing with this is it's sodium phosphate. The sodium is measured in milliequivalents. The phosphate is measured in millimoles. So it depends on how they want to calculate it. And since they're calculating this by the sodium, they're going to look for milliequivalents. So, you know, 12 MEQs, you have to go for the one with MEQs. You cannot divide milliequivalents by millimoles, because in this case, well, in any case, all of these things are going to be different depending on what their chemical formula is. So sodium phosphate is NaPO4, and the ratio of sodium to phosphate is, you know, you can't just exchange millimoles for milliequivalents. It doesn't work that way. So we want 12, and 15 mLs is going to give us 60 MEQs. So I'm going to need a lot less than 15, right?
Yeah, correct.
So I have 180 divided by 60, which comes out to be 3 mLs. Is that correct?
Yep, that's correct.
Now, if you had used the 45, you would get a larger number, and that would be wrong. So you want to make sure that you're looking at your units and making sure they're the same units. Okay? All right.
Okay, Professor, I have a question on that. So it's the 15 over the 60 times 12 milliequivalents?
Yes.
Is it only for that one or for all the problems?
No, that's only for sodium phosphate.
Okay.
Yeah. But the reason I'm talking about this one is because it gives you 2 stock strengths available. And it's actually the same bottle, but in one case, they're measuring the millimoles, and in another case, they're measuring the milliequivalents that are available. So that's like saying, you know, I'm baking something with only 2 ingredients, and it has this much of this per cup and this much of this per cup. And so they want you to calculate how much to give based on, I don't know, the sugar or the flour, right? So you have to make sure you know which one you're looking at. They're asking for milliequivalents, so when you want to make sure you go to milliequivalents for that. Does that make sense?
Yes, yes, because
Okay.
I set up everything with milliequivalents on top, mLs on the bottom for the rest of the problem, times the milliequivalents they're asking for on the right-hand side. So,
Okay.
is that correct or is that wrong?
Okay, so you did it like this.
Right, but on the rest of the problems as well. So I wasn't sure if that was the correct setup. No, you get too many with that.
Did you do it that way?
Yes.
Okay, and you ended up with 3?
No, it ended up with 48, I think. It was a lot.
Okay, because you probably multiplied straight across, right? And in this case, if you're going to use, this is the ratio and proportion setup where you have the same units on top and the same units on the bottom. When you do a ratio and proportion setup, you have to cross multiply.
Okay.
So you would have 60x equals 15 times 12, which is 180. And then when you divide both sides by 60 to get x by itself, you have right here exactly what you have here, yes? So you'd still get 3 mLs. So this is why I show both ways to do this problem, but you really have to decide which one you want to use and be consistent. And the reason I usually go with dimensional analysis is because it allows you to continue on with that using more and more things into one equation. Whereas this, you can only compare milliequivalents to milliequivalents. So it's great for dosage calculations, but now if you're trying to do some more complicated problems, you would have to do 3 or 4 of these ratio and proportions. And if you use dimensional analysis, you could set it all up in one problem. Okay, so that's why I use a lot of dimensional analysis. So a good example of this is, let's see. So this is an example off the top of my head. It's not in your book. All right, pen. I'm just hoping I can get through the semester without buying a new pen. Okay, so we want to know how many 20 milligram tabs are needed to make 480 milliliters of sildenafil solution, oral solution, 10 milligrams per milliliter. So your final concentration is going to need to be 10 milligrams per milliliter. You want to make a whole pint of it, 480 milliliters, and you're using 20 milligram tablets. Now, just as an aside, why would we need to make sildenafil oral solution? What is sildenafil?
I have no idea.
It's Viagra. So wouldn't a man just be able to swallow a tablet? Well, we actually make this for babies in the NICU because it lowers peripheral arterial blood pressure kind of thing. It has something to do with the blood pressure around their lungs, okay? So I don't know too much about it, but it works really well for that. So we have a lot of babies in the NICU and also younger babies that are in the other part of Children's Hospital that take this. I don't remember what the exact concentration is that we make, but this is the type of problem that you see on exams a lot, okay? So we want to know how many 20 milligram tablets. So we're going to start with 1 tablet is 20 milligrams. We want to end up with 10 milligrams per milliliter or 1 milliliter, and we want to make 480 milliliters total out of it. So the milliliters are going to cancel, the milligrams are going to cancel. And now, I think my pen is starting to come apart at the tip. Now, when I answer the question, I'm going to end up with tablets because that's the only unit left. So 10 times 480 is 4,800 divided by 20.
$240.
Yeah, so I would need 240 tablets. So if I were doing this in ratio and proportion, I'd have to do 2 separate problems, okay? So I'd have to do, you know, I'd have to figure out how many milligrams I need in 480 milliliters And then I'd have to do another problem and divide it by 20 milligrams per tablet. So, you know, that's one way these problems can be done more quickly, is by using this dimensional analysis, okay? So that's a question there. I had a student in one of my math classes about a year ago. It was when we were in class, of course, and I let them out, and he came back a few minutes later with his girlfriend who was in the nursing program, and she was showing me her nursing homework, and she was saying, you know, I have this one problem, can you help me with it? And I don't remember the exact problem, but it was something like, you add this many milligrams to this size bag, and you know, what's your final concentration? And then it says, you need to, after so many minutes, how many milliliters are left? Well, now the doctor changes the order to this higher concentration. How many milliliters from this stock bottle do you add to your remaining bag to make it this particular concentration? And I was looking at that thing going, okay, first of all, number one, you would get a new bag from the pharmacy, period. You would not add anything to this bag that's already hanging there, okay? Unless you're working in, you know, a third world country with a nonprofit organization, yeah, you might have to do that because maybe that, you know, you're really low on bags and you don't want to waste any of them. So just, you know, for the sake of this hypothetical, let's go ahead and do this problem. So when you guys are you know, thinking about going into nursing and you're looking at these problems going, how does this relate? You might not compound this particular sildenafil oral solution because we do it in the pharmacy. But on the other hand, you're going to get questions like this because they want to know, do you understand the math involved? And you're going to get problems or questions like the one that that the girlfriend showed me, that I had to think about it for a minute because, you know, you know, it's very complex. And like I said, it's not something we would do, that particular problem, but you'll see it. And so it's important that you guys understand that it, as hairy as this math looks to you guys now, you're going to see worse when you get into nursing. So it's really important that you have a good foundation on this. Okay, does that make sense?
Yes.
Okay.
Completely
And
makes
just
sense.
like anything else, how many of you love to parallel park?
No.
No, not me.
Do you go out of your way to avoid parallel parking?
I'm sorry? Yeah.
Do you go out of your way to avoid it? Yes.
Yeah, most definitely.
I go out of my way to avoid it. Definitely. So I almost never parallel park, but I had to show when I was taking my driver's license test that I know how to parallel park. At least they did that a long time ago when I did it. They made me parallel park before they would give me a driver's license. So it's kind of like that. You're gonna have to learn things that you may never use again. Like, you know, seriously, my pharmacists have taken calculus, never once used it after they passed their exam. So, you know, it's just what it is. You're showing basically that you have the capacity for doing it. And then they figure, well, if you are overeducated, we know you can do this job. Does that make sense? Kind
Yeah.
of?
Yes.
Okay, good. So what other things are you guys having questions on? Because we have this week, next week is the 10th when we're going to do another review session, and I'm going to probably do another evening one as well. And then you have your final the following week. So I do want to look at chapter 17 real quick.
I have one question about the reconstitution for
Yes.
the beyond use date.
Okay.
Like if I have it, if the initial date or the reconstitution on December 2nd, 2020, and it's work for the 10 day. So the beyond use day, I just add 10 days for my date. That's it.
Yep.
It will be like December 12th.
Yep.
Okay.
Now you could technically say, like right now it's 2:40 p.m. You could say at 14:40, but most people, they're just going to say at the end of the day, because it doesn't matter what time during the day you reconstitute it. You can go to the end of the 10th day and you're fine. It's not that crucial. You're okay, for
Should I put the time?
no.
Okay.
Yeah, and most people are going to go, oh no, today's the 12th, and throw it away anyway, even though it's probably okay for the rest of that day.
Okay.
Yeah.
Thank
So it
you.
really depends. So you have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so then it should expire on the 12th, but most people are fine till the end of that. So there's a little bit of breathing room.
Okay, thank you.
You're welcome. Now, I do have a hypothetical for you. Let's say that you're reconstituting it yesterday on 12/2, and the bottle expires, before you reconstituted it, expires 12/09. Can you put 12/12 as your expiration date?
I think no.
No. You would have to put 12/9/20. Okay, so it's as long as it cuts down the expiration date, you can do the 10 days. And this doesn't come up that much with community pharmacy, because if we have something that expired on the 9th of December, we're getting rid of it in like October. You know, we don't keep it on the shelf till the very last day.
Okay.
Okay, but in hospital pharmacy, we kind of see this with tablets. We'll have a tablet that expires May 1st. And if we, let's say that we're going to repackage it or cut it in half. If we cut that tablet in half and repackage it in unit doses, then it's only going to have 6 months on it. So if it expires in May and this is December, then we're okay. But if it expires in January and this is December, we can't put 6 months on it, right? We can only put up to the time that it officially expires. Why are you falling apart, Pen? Stop that.
Professor Lopez, I have a question on number 3 from the post-test.
Yes.
I don't know what I'm doing wrong, but it's the second question, second portion of number 3, where it says, what is the flow rate in milliliters per minute?
Okay.
And I end up with a 0.83.
And what does the key say?
It's right. Yeah. I end with the same.
Okay. And I want to say the Q says 0.9. I don't know how it's like rounding up. Let me go back and look at that. Sorry.
All right.
That was number 3. And that kind of throws me off for like the following question then.
Okay. Now, how many milliliters did you add to the bag?
It would be 4 mLs, right? To the 100.
4 mLs. Oh, so add the 100 to 4? 104?
Yes. Now, when you do that milliliters per minute, 104 divided by
the
60.
2 hours.
Yeah.
It's 2 hours, right?
I did it by
Yes.
120.
120. Okay. And that's 0.86.
They rounded it up to the.
That's what it is. Okay. Makes sense.
Okay. Did I answer your question?
Yes. Thank you, guys.
Good, because I'm fiddling with my pen.
No, I got it. Thank you. Thank you very well.
This is
You're
called,
welcome. Trust me, I worked on all these problems. I have so many erase marks on these pages. Ms. Lopez, I'm sorry.
Me too. Me too.
that's quite all right. That's quite all right. If you get to this point, just put a box around your answer and I'm fine. If
Like
you,
in question 3, I left all the post tests for like the whole day. Then I come back because I.
Oh, I bought special pins that erase, so hopefully that it's not too bad.
I'm sure it'll be fine. As long as I can see what the answer is and I kind of see where you were going with your working out the problem, we'll be fine. This is dang frustrating. I'm telling you guys, I'm going to have to, I'm afraid I'm going to have to go back to the whiteboard, which will not be fun because then I'll have to bring my phone in and that takes me forever. So we'll see if this is actually working. Yes, okay, good. Maybe I'll try not to touch it while I write with it. Okay, let's look at chapter 17 real quick, just because I can say I went over it. I'm not testing you on it. And the reason for this is it's a good, just a good business lesson period for any healthcare field. You know, you have overhead expenses, which is things like your, where'd it go? Overhead is things like rent, wages, utilities, insurance, licensing fees, depreciation, taxes paid, and other costs of doing business. Anything that's not inventory, okay? Because you're basically, you're selling something, right? So in pharmacy, at least, we're selling medications. And then when you're figuring out your profit, you have two kinds of profit. You have the gross profit on page 454, which says the sales price of merchandise minus its purchase cost. It usually refers to the total income for a business, and that's called gross. Now you have to take out your overhead, which is the net profit. So it refers to the total income for a business. It's the gross profit minus the overhead. So let's say that you you buy a t-shirt for $10 and you turn around, that's your cost, and you sell that t-shirt for $25, which is your selling price. Then how much is your profit? How much did you make on that t-shirt?
$15.
Okay, that was weird. So it's 25 minus 10, which is $15. And what is that? Is that gross or net? Gross is the more disgusting one because you still have to subtract the net. So this is your gross profit before expenses. Come on. So let's say that you figure out after you pay rent on your little kiosk and you pay insurance for the person that you're paying to work there and you pay their wages and you pay for your little light strip that you've got on your little kiosk and you figure out your cost per day and how many t-shirts you sold that day and you figure out that it costs you $6 in overhead. Now how much is your profit on the t-shirt?
$9.
Yeah, it's going to be $9 because 15 minus 6 is 9. It's hard to figure out net. That's your net profit. It's hard to figure out net profit on an item. Usually, you're going to figure out net profit on the whole business. Okay, so you're going to look at all the t-shirts you sold like in an entire month. Then you would subtract your month's, you know, stuff. Okay, to get your net profit for the entire month. So that's like the first thing that they show you. Okay, so if you read over all of these keywords, there's a bunch of them, and if I read them all, you are literally going to go to sleep, and so will I. Okay, so the purchase price is also called the wholesale price. I mean, the purchase cost, how much you pay for something, can be called, so this thing right here, cost, how much you pay for what you're selling, can be called the wholesale price, acquisition cost, or the inventory cost, okay? So one of the things that we do in pharmacy is we decide how to mark something up in order to make a profit on it. So if you go over to page 457 and we look at the introduction, it says that pharmacy technicians in retail settings, as well as in hospital settings, may be involved with business calculations. I actually, now in the hospital, we have pharmacy technicians who do billing. They don't do anything else but billing, depending on how large the hospital is. But for most medium and large size hospitals, they're going to specialize in billing. And they can actually, depending on you know, how good they are, they can make a decent wage doing billing, because we always want, you know, we have to pay our expenses. And even a nonprofit company has to pay the people that work there unless they're volunteering. And they have to be able to pay the rent, even if they're getting a break on their rent because they're a nonprofit. So even a nonprofit company has to keep track of the money that comes in and the money that goes out, right? So you might think, oh, all they care about is profit, but really profit just means that you don't owe money to anyone. And you don't want to end up going long periods of time owing money to anyone, because then they stop, you know, sending you things. So, you know, profit is not necessarily a bad thing. My husband has a business degree and he worked in sales, so he's much better at this than I am, I have to tell you guys. Okay, so for a business to remain profitable, the net income or net profit from the sales of medications must exceed the cost of doing business. So that's the main thing that they keep calling overhead, is the cost of doing business. So it's not just the wages you pay your people. It's not just the insurance that you pay. It's also things like, if you own the shopping center, you have to pay the person who comes in once a month with their little Zamboni and cleans the, you know, like a street sweeper. They come in and clean the parking lot. I mean, all kinds of weird things. The light bill, the cost to repair the drywall after somebody got mad and threw something at it, you know? I mean, it's crazy, all this different overhead. Depreciation, which I'm not really going to get into, it's basically things are worth less over time, right? So your building gets older, but then the rent increases even though the building's older. And this is why I actually dropped accounting my first semester in college. You know, I'm 17 and a half and I'm signing up for these classes for the first time and I have no idea what I want to do. Pharmacy wasn't even on my horizon in my brain at that time. And depreciation just freaked me out. You know, like, why would your car be worth $600 here, but you paid $16,000 for it, but now it's only worth $200? You know what I mean? I mean, it's really weird. So this is why I don't have a business degree and my husband does. Okay, so if you look at example 17.1, it gives you some depreciation, but I'm not going to go into that example because I don't like it. Okay. Let's look at markup, which is over on page 459. The markup amount is the difference in the purchase cost of the drug and the selling price of the same drug. So markup is similar to gross profit, right? So if you pay 25, if you pay 10